The slide rule is used to solve mathematical problems and to solve them quickly. Here, the rule is being used for the calculations in designing a bridge structure. The slide rule provides answers that are accurate to the degree required in most engineering problems. Although the slide rule may appear complicated, it is based on simple principles. To explain these principles, we shall use only part of the rule, the lines of marks and numbers called the C and D scales. These scales are used principally for multiplication and division. Substituting a rule with enlarged figures will make the scales easier to read. On this rule, the C and D scales are exactly the same as on the standard rule, except that the figures are enlarged. As on the standard rule, the C scale is on the slide, which can be moved back and forth. The D scale is on the body of the rule. This mark, numbered 1, is the left index of the C scale. This is the right index of the C scale. A hairline, which assists in reading the rule, is on a runner called the indicator. For the time being, we shall simplify the rule by removing the indicator and the subdivisions of the scales, leaving only the 10 main divisions. By solving simple multiplication problems with this rule, we can learn the procedures used with all slide rules. Let us start with some problems to which you already know the answers. First, 2 times 2. 2 times 2 equals 4. To multiply 2 times 2, first find 2 on the lower scale, the D scale. Next, set the index of the C scale opposite the 2. Then find 2 on the upper or C scale. Read the answer 4 directly opposite on the lower or D scale. The slide rule procedure can be diagrammed like this. 2 times 2 equals 4. Ordinarily, the problem would be written like this. On the slide rule, it takes this form. With the index set opposite 2, we can multiply any number by 2. 2 times 3. 2 times 3 equals 6. 2 times 4. 2 times 4 equals 8. To multiply 3 times 3, find 3 on D. Set the index to it. Find 3 on C. Read the answer, 9, directly opposite on D. Multiplying 4 times 2. 4 times 2 equals 8. The procedure for multiplication is always the same. To multiply 4 times 20, read in the ciphers mentally. 4 times 20 equals 80. Likewise with 30 times 3. 30 times 3 equals 90. 2 times 20. 2 times 20 equals 40. Other ciphers may be read mentally as required by the problem. Thus, 2 times 200 equals 400. 20 times 200 equals 4,000. So far, we have used only the left index. Now let us try to multiply 4 times 5 using the left index. We find that 5 on C is beyond the body. Whenever one index cannot be used, use the other. In this case, use the right index. 4 times 5 equals 20. Here again, read in the cipher mentally. Multiply 4 times 50 in exactly the same way as 4 times 5. Simply add the ciphers. 4 times 50 equals 200. Just as you read in ciphers when required by the problem, you also read in decimal points when required by the problem. For example, to multiply 4 times 0.5, read the answer 2.0. With 0.4 times 0.5, read 0.20. With 2 times 0.02, read 0.04. In reading the slide rule, always remember that ciphers and decimal points are placed mentally as required by the problem. To obtain the simplified rule used in these examples, we started with the C and D scales divided exactly as they are on the standard rule. We then removed the subdivisions of the scales, leaving only the main divisions. Now let us replace and use the subdivisions. First, each of the main divisions is divided into 10 parts. Between main positions 1 and 2, the subdivisions are numbered. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th subdivision bringing us to position 2. Beyond 2, there is not enough room to number the subdivisions, but they are read as though they were numbered. 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th bringing us to position 3, and so on throughout. With the main divisions divided into tenths, let us use the indicator to read some of the positions. By mentally placing ciphers after the figures denoting the main positions, we may read 10, 11, 12, 13, 18, 19, 20, 21, 22, 90, 91, 92, 97, 98, 99. Now each tenth of each main division is further divided. Within this bracket, each tenth is divided into 10 parts. Taking 1 as 100, we read 100, 101, 102, 103, 110, 111, 112, 198, 199, 200. Within this bracket, there is less room for the marks, so each tenth is divided into 5 parts, each part read as a 2. For example, 200, 202, 204, 206, 208, 210. Within this bracket, there is only space enough to divide each tenth into 2 parts. Here, the smallest divisions are read as 5s. For example, 400, 405, 410, 415. To review, each main division is divided into 10 parts. Then, these tenths are subdivided into as many divisions as there is room for. 10 in this bracket, each being read as 1. 101, 102, 103, and so on to main position 2. 5 in this bracket, each being read as 2. 202, 204, 206, and so on to main position 4. 2 in this bracket, each being read as 5. 405, 410, 415, and so on to the end of the scales. Remember, any position on the rule may be read with ciphers and with decimals. For example, we read this position as 12. It may also have these readings. The same holds for any position on the rule. The scales are here divided and read exactly as they are on the standard slide rule. The procedure for multiplication remains unchanged. To repeat, using the hairline only, set the hairline on 2, and to it, slide the index of C. Move the hairline to 2 on C. Under the hairline, read the answer 4 on D. Now let us take a few problems using the full scales. First, 192 times 2. Set the hairline on 192, 190, 191, 192, and to it, set the index of C. Move the hairline to 2. Under the hairline, read the answer 384 on D. 300, 350, 60, 70, 80, 380, 2, 4, 384. Remember, the settings and procedure would be the same if ciphers and decimals were involved. As another example, let us take 243 times 2.5. Set the hairline on 243. 243, as we see, does not fall on a mark, but its position may be found quite easily. First, find 242, 200, 210, 20, 30, 40, 240, 2, 242. Since the next mark is 244, we know that 243 is in between, about here. Having found 243, slide the index to it. Now move the hairline to the position for 2.5, and under the hairline read the answer on D. The answer does not fall on a mark. However, it does fall about halfway between 605 and 610. Therefore, we conclude the answer is 607 1/2, or in terms of decimals, 607.5. Remember, the procedure and settings would be the same for these problems. To place the decimal point and the ciphers, we must approximate the answer mentally, but the procedure with the rule is always the same. We have found that the steps in multiplication always follow this sequence. To divide, we merely reverse the procedure. To divide 4 by 2, find 4 on D. To it, slide 2 on C. Opposite the index, read the answer, 2, on D. To repeat using the hairline, set the hairline to 4 on D. To it, slide 2 on C. Move the hairline to the index, and under it, read the answer, 2 on D. To divide 9 by 3, set the hairline to 9 on D. To it, slide 3 on C. Move the hairline to the index. Under the hairline, read the answer, 3 on D. Any problem in division is worked the same way. 720 divided by 90. Set the hairline to 72. To it, slide 9 on C. Now, since the left index is beyond the body of the rule, move the hairline to the right index and read the answer, 8 on D. In division, as in multiplication, place the ciphers and decimal points mentally. Some problems, like this one, involve more than one step. However, we use the same basic procedures. In a problem of this kind, start with the division. In this case, divide 2 by 3 as the first step, and multiply the result by 6 as the second step. We know that to divide 2 by 3, we set the hairline to 2 on D, and to it move 3 on C. The answer will then be opposite the index on D. But in this case, the answer to the first step is to be multiplied by 6 in the second step. With the slide rule, there is no need to read this answer. Simply leave the index in position on the answer, and, to multiply by 6, move the hairline to 6 on C, and read the answer to the complete problem, 4 on D. Notice that solving this problem requires only one setting of the rule, and that there is no need to read the intermediate answer. Ordinarily, the slide rule is used for problems much more complicated than those we have been solving. Here, the slide rule was used to solve this problem, and this is the answer obtained. Working this problem by longhand would take longer and would provide this answer. The slide rule has quickly provided the answer needed. An engineer seldom needs the final digits arrived at by longhand. For most calculations in engineering and estimating, round figures are sufficient. The slide rule furnishes these quickly, and they are accurate to the degree required. Speed in using the rule for the solving of complicated problems requires practice. But remember, the procedure for multiplication is always the same, regardless of the problem. Likewise, the procedure for division is always the same, regardless of the problem. Always approximate the answer mentally to supply the ciphers and place the decimal point. To the slide rule, any problem is as easy as 2 times 2.